Have you ever really thought about something as simple as bending your arm? It feels like nothing, right? But underneath your skin, there's this incredible biological tug-of-war going on every single second. Today, we're going to pull back the curtain on the really elegant and actually super simple system that your muscles use to create every move you make. So let's jump right in.
All right, so here's the game plan. We'll start with the basics, your body's engines, aka your muscles. Then we'll get into this one weird rule that changes everything and how nature came up with a perfect solution. We'll see it in action in your arms, then your legs, before we wrap it all up with the most important things to remember. Okay, first things first. Let's talk about the powerhouses themselves. You can pretty much think of your muscles as the engines that drive your whole skeleton, making everything possible, from walking to just waving hello. And we're talking specifically about what are called skeletal muscles.
And hey, the name kind of gives it away, right? Skeletal literally means it's part of your skeleton. These are the muscles that attach right onto your bones, and they have one main job: to contract, to get shorter. And when they do that, they pull on your bones and make your joints move.
But here's a cool detail. Muscles don't just, glue themselves directly onto the bone. They use a middleman, these super strong fibrous cords called tendons. So when a muscle contracts, it pulls the tendon, and the tendon yanks on the bone. That's how you actually get movement.
So muscles pull on bones. Seems simple enough. Well, this is where it gets really, really interesting, because these incredibly powerful engines have a very specific and kind of surprising limitation. It's a core principle that we can call the one-way rule.
And that's it. That's the whole rule. Muscles can only create force by pulling. They can contract and get shorter, and they can relax and go back to their normal length. But they have zero, absolutely no ability to actively push anything. And that creates a bit of a problem.
Which leads to a pretty obvious question, right? If the muscle that bends your arm can only pull it shut, what opens it back up? How in the world do you straighten your arm if nothing can push it straight? This is the central puzzle we need to solve.
And nature's solution is it's genius in its simplicity. It's teamwork. To get around this whole only pulling problem, muscles never, ever work alone. They always work in pairs.
And I absolutely love this analogy from the source material. It's just a perfect way to picture it. You wouldn't put on just one shoe, would you? Well, in the same way, your body doesn't use just one muscle to work a joint. They always come as a matching set.
Now, the official science-y term for these pairs is antagonistic muscles. And antagonistic just means they work against each other. So while one muscle is busy contracting and doing all the pulling, its partner on the other side of the joint has to chill out, relax, and stretch. They basically take turns being the boss.
Okay, let's see how this actually works with probably the most famous muscle duo in the entire body, your biceps and your triceps, right there in your upper arm.
And this lays it all out perfectly. When you bend your arm, like you're doing a curl, your biceps on the front of your arm contract and pull. But, and this is key, at the exact same time, your triceps on the back have to relax to let that happen. Then, to straighten your arm, the roles flip completely.
So let's actually walk through it. Go ahead, flex your arm right now. Feel that muscle popping up on top? That's your bicep, contracting, pulling your forearm up. Now straighten your arm out. Feel that muscle on the back of your arm getting tight? That's your tricep, and it's contracting to pull your arm straight while your bicep just relaxes. It's a perfect handoff every single time.
And this isn't just some weird thing your arms do. Nope. This exact same principle is at work all over your body. So let's look at another really powerful example: the muscles you use to kick a ball. So for this move, the main players are your quadriceps, the big muscles on the front of your thigh, and your hamstrings on the back. To get ready for a kick, you pull your shin back, right? To do that, your hamstrings have to contract. Then, to actually kick forward, your quads contract like crazy.
So it's this perfectly timed two-step dance. First, the hamstrings pull the leg back, kind of loading it up like a spring, while your quads relax. Then, the jobs flip. The hamstrings relax, and the quadriceps fire, contracting to swing your leg forward with a ton of force. See? Perfect teamwork.
So, as we've seen, every single bend, every stretch, every little movement is a coordinated effort. It's this constant, invisible teamwork happening all over your body. Let's just quickly run through the most important points one last time.
All right, let's lock this in. First, those muscles that move your skeleton around, they're called skeletal muscles. Second, don't forget their big limitation. They can only pull, they cannot push. And because of that, they always have to work in these opposing or antagonistic pairs. And we saw that perfectly with the arm. To lift your forearm, the biceps contract and the triceps relax, and to lower it, they just swap jobs. Simple as that.
And that kind of brings us to a final thought. Now that you know the secret, this elegant system of partners pulling against each other, one contracting while the other relaxes, just think for a second. How many of these silent antagonistic pairs do you figure are working in perfect harmony just to let you hold your phone or sit in your chair right now? The answer is a whole lot, and it's happening all the time without you even thinking about it.